The following video is going to examine the relationship of slope with parallel and perpendicular lines. For parallel lines do not intersect. They have the same slope since they are parallel. So parallel lines have the same slope. The slope of one line, M1, is going to equal the slope of another line, M2. For perpendicular lines, though, perpendicular lines, if I were just to sketch an example, and you can kind of see if I want a line perpendicular, it creates a 90-degree angle. They're going to have opposite slopes, but they're also going to have reciprocal slopes. So opposite means they're going to have different signs, opposite signs, and reciprocal means flip. So perpendicular slopes create the right angles. They have opposite signs. If one's positive, the other's going to be negative, or vice versa. If one's negative, the other's going to be positive. And the slopes are flipped. So let's examine some problems. Graph the following line that goes to the point 6, -2, and is parallel to -4x plus y equals -2. So the first thing we're going to do is we know we're going to have parallel line that goes through 6, -2. So I have a point that I'm going to start at when I sketch. And I also have an equation that it's parallel to. So what I'm going to do is I'm going to take that equation, -4x plus y equals -2, and I'm going to convert it to slope-intercept form. That'll allow me to see what the slope is in the equation. So I add 4x, that cancels out the -4x, and then I have y equals 4x minus 2. So if I'm parallel to the slope here, parallel is the same slope. And so when it comes to this line, y equals 4x minus 2, since it's the same slope, the slope I'm going to use will be 4 as well. So what I do is I go to 6, -2, plot a point. I go up 4 to the right 1, up 4 to the right 1. I could also go down 4 and left 1, and then connect these with my line. And so that is the graph of the equation that is parallel to -4x plus y equals -2 and goes to the point 6, -2. So now let's try another example. Graph the line that goes through the point 3, 4. So again, I'm given my point 3, 4. I know I'm going to plot that point, and it's parallel to x plus y equals 4. So I'm going to do the same idea. I'm going to take x plus y equals 4, and I'm going to convert to slope-intercept form by subtracting x. So I get -x plus 4. And so again, parallel lines means you have the same slope. And so though we don't see it, there's really a -1 here. And so the slope I will use with my line is m equals -1. So I start at 3, 4. I have a slope of -1, so I go down 1, right 1, down 1, right 1, and so on and so on and so on. I go up 1, left 1, and so on and so on and so on, and then connect those with a line. And so that's parallel. You're given the point, given the slope through changing to slope-intercept form and applying the definition of parallel lines have the same slope. So let's examine perpendicular lines. So it's generally the same idea. You're given your point 1, 2, so I know I'll start by plotting my point 1, 2. But this time I'm told it's perpendicular to -2x plus 3y equals 6. Still the same concept. In order to find the slope, we're going to convert it to slope-intercept form. So I'm going to add 2x to both sides to get 3y equals 2x plus 6. And then I'm going to divide every number by the coefficient of y, which is 3. So that gives me y equals 2/3 x plus 2. And so I'm looking at being perpendicular to the line that has represented by the equation, y equals 2/3 x plus 2. And so remember, perpendicular means that your slopes are opposite reciprocals. And so that means do the opposite sign. So the opposite of positive 2/3, well, it's a positive, so I'm going to have a negative. And then I have to flip what's given to me. So 2/3 becomes 3/2. So the slope I will be using is -3/2. So I plot the point 1, 2. I have a slope of -3/2, so down 3, right 2, down 3, right 2, and continue that pattern. I could also start at 1, 2 and go up 3, left 2, and up 3, left 2, and then connect those with my line. So it's the same concept as what we did parallel. You take the equation that you're given, convert it to slope-intercept form, examine the slope, and determine what you're dealing with, whether it's perpendicular or parallel, whether it's opposite reciprocal versus same. So last example we'll be doing with parallel perpendicular lines. Graph a line that goes through the origin and is perpendicular to y equals 1/2 x minus 3. So this one's telling me it goes through the origin. Now remember, the origin is the coordinate 0, 0. So it is giving me a point where my graph starts. Perpendicular to y equals 1/2 x minus 3. It's already in slope-intercept form for me. And so perpendicular means opposite reciprocal. So I'm going to, it's a positive 1/2, so I'm going to use a negative. And then I have to flip what's given to me. So you'll say -2/1. But remember, we always simplify. Anything divided by 1 is just itself. So I'm going to use a slope of -2. So I start at 0, 0. Use a slope of -2. So down 2, right 1. Down 2, right 1. I could go back to 0, 0 and go up 2, left 1. And then connect those with my line. So overall, we have to make sure we can identify what our slope is on what we're parallel perpendicular to, and then apply our definitions of parallel slope and perpendicular slope. Parallel slope is the same, and perpendicular slope is opposite reciprocals, which means different signs for the slopes, and flip what is given to you.